Good evening, ladies and gentlemen. WeatherBrains episode number 962 for the 24th of June, 2024. We are back on our regular Monday night schedule here. Back in the saddle again. We took last week off, but we did two shows the week before. We have not missed a single week since January of '06 when this show started. Who'd have thunk it? And again, we're coming up fast on show 1000 here. We've got to get a plan for this. But anyway, if you are new here, welcome to the pre-show. This is the magical, marvelous time where we share three things: boring personal stories, humorous anecdotes, and on occasion we say outrageous things. So yes, for longtime viewers here, you know the deal. I take a week off every year in June. Typically, it's the third week in June. I volunteer at a church. Our big children's activity for the summer is VBS, and that's it takes every CPU cycle in my brain, every ounce of energy that I have. And after VBS week, that's when I take the vacation week. And so last week was vacation week. Had a great time. Spent a couple days in Boston. As always, we like to watch a little Red Sox baseball. And we saw the Sox and the Yankees at Fenway. Gets no better than that. And the Sox won both games. In fact, we've started these guys in a good role here. I think they've gone 7-1 since we went to Boston. Got to see Stephen Quinn. Stephen, for those that don't know, worked here as a news anchor at the local TV station where I work, and he is now with WHDH News 7 in Boston. But Stephen's, we are polar opposites, the odd couple. He's a Yankees guy. I'm a Red Sox guy. He's an Ole Miss guy. I'm a Mississippi State guy. But we have a lot of fun together. Great to see Stephen. He came. We watched one game together. And had a really good time there. Came back and then went to the Canadian Rockies. Ooh. Oddly enough, at my ripe old age, I have never been across the line to Canada. How weird is that? I mean, I could throw a rock and hit Canada from many places I've been over the years, but I've never crossed over into Canada. So we went to Alberta, flew into Calgary, went over to Banff, Canada, Alberta, and it was amazing. It was refreshing. Highs around 50 and lows in the 30s. We were eating dinner one night with snow falling. How about that? Light snow here in the middle of June. But they had a great time. And if you've been to Yellowstone, any place like that, you are aware of the beauty of the Rocky Mountains up and through there, but it was just gorgeous. We went to Lake Louise, Lake Moraine, Lake Minnewanka. Got out there on the boat on that lake and just had a great time. And everybody needs a break. And I've talked about it here before, and we all have, I think, in that what we do, it is somewhat pressure packed. And times have changed. When I first started doing this years and years ago, I literally worried about two things: being on television at 6 o'clock and 10 o'clock. I don't know what I did with all of that time. I really don't. So we've gone from that to now where I'm basically working. And again, this is no complaint. I love what I do. I cannot wait to wake up in the morning and do what I do. But I pretty much work from 4 a.m. until midnight with some breaks every day, weekdays. And during that stretch, I'm doing a morning shift involving television and commercial radio. I do, of course, commercial television here at our TV station, and do 24 radio stations, 24 radio stations around the country, write a meteorological discussion, do a live briefing on YouTube and Facebook. Then I go speak somewhere every day, and it doesn't stop. But my first openings are now in late 2025. I'm almost booked in 2025. The first chance for me is almost 2026 now. And it's marvelous. Mostly at schools. And I've said this before. If I did not do this for a living, I would teach third grade science. I would love that. Come back in here, do the same thing, and when you work a schedule like that, everybody needs a mental health break. I don't care who you are, who you think you are, how strong you think you are. Everybody needs a little break. So it was very nice to have a break. Ooh, I can see Cameron this week.
What's
We
going
couldn't see him
on?
last time.
James, the
Gosh, if
first
I
talk that I ever heard you give, you said something like, as soon as I entered this workforce, I just never slept after that. Do not envy you.
yeah. No, it's I love it. I absolutely love what I do.
Yeah,
I was talking I took a vacation week last week. It's the first week I take every year. It's always in mid-June.
look at you.
And we went to the Canadian Rockies and just got off the grid and just, and everybody needs that, I think. And so it was good. But
Yeah,
anyway, it was
good.
so we're back on our Monday night schedule. We have your video, we have your audio, and life will be much better this go round.
I'm not in a car and I have internet.
Yeah. Yeah, and again, we warn everybody here. We're live on YouTube, but we're not recording the audio. About 75% of the people listen to this is an audio show.
Yeah,
25% watch it
right.
on YouTube, and we go live on local television here at 7, and we'll start the recorders for the audio at 7. So this is why we always say during the pre-show. This is when we say obnoxious things, boring personal stories, and humorous anecdotes. It's
Perfect.
the special part of the show here. I think James, I don't think Bill Murray is going to be on tonight. I think he's on a pub crawl. So, or 50 cent beer night at Hooters. We don't know which one it is. It's one of the two. So James Adelot will be leading the discussion from Tulsa Town. And if not, we all have a gazillion questions. And what's odd, I see Kim and Rick are with us, but I don't see their video. I mean, how strange is that? Um, there we go. All right. Now they're all popping on here. Um, so hopefully Dr. Jacobs will be here. But we can't start until the top of the hour. So we've got less than a minute and we'll get it started here. And James A., you were leading the discussion, I understand.
Yeah, how'd that happen?
Well, it's because you're a PhD guy. Aren't you PhD now?
Not yet. I'm hoping spring of next year. So fingers crossed.
It's bad. I guess I'll have to go back to school. I feel like I'm so undereducated compared to all these Einsteins on the show here.
It doesn't
I
mean that you're smart. It means that you're stubborn, bullheaded, have a complete lack of perspective with what to do with your life.
That
That
is
kind
what
of
I
stuff.
tell everyone.
and that's a perfect description of me. So I mean, it works. That works out
See?
well. And welcome to our television viewers. It is Monday night. We're back on Monday night this week. And actually we were on for the television viewers. We were on Monday night last week. We just had a recorded show, but we're live. So let's get the recorders going here. Track number 1 and track number 2. And here we go in 5, 4, 3, 2, 1.
You've heard James say it a million times. Respect the polygon. At Weather Call, we call, text, and email you when you're in the polygon. So in a way, we make the polygon better. With solutions for personal use, businesses, schools, pools, playgrounds, and RVs, there's a Weather Call solution that's right for you. Check us out at weathercallservices.com.
You're listening to WeatherBrains. They're kind of a big deal.
Well, Bill Curtis says we're kind of a big deal. Maybe we are, maybe not. Whatever. Hey, we're here. This is WeatherBrains, episode number 962. 962 for the 24th of June, 2024. We have passed the solstice and we are now into summertime. Summertime. Oops, you guys ever hit the wrong button? You'd think at this age I would know how to hit the right buttons here. Rick Smith, how hot was it in Norman today?
It was hot enough. I don't know exactly what we got up to. Close to 100, probably. Heat index was well above that. So Anything above 95, who cares? It's hot.
Yeah, I don't know if I could tell the difference between 98 and 102. I just don't know if I could tell the difference. I can't tell the difference in the dew points. We were very blessed today. Our dew point dropped to 59 here. And so the humidity was like 22% at mid afternoon. So we were very, very, very fortunate. Let's see here. I thought we had Kim on the line, but I don't see her. I don't see. And again, it's summertime. And again, for those that were not with us last week, we recorded last week's show early because I had vacation. We have a lot of vacations this week, but James ate a lot. Let's go right to you and let's get right into this because we had we were on the verge of one of the greatest shows ever a few weeks ago. On the verge, but we're going to make it happen tonight.
We will make it happen. The redo, version 2.0, the fix, the service pack is in.
Yes.
Yeah, and it was impressive because every time Dr. Nixon was just about to make this incredibly wonderful, profound point,
So I just wanted to know, I think my default in that kind of position is just to like freeze and just pretend like nothing's happening. Just kind of carry on like normal. I was like, I lost my cool. I lost all of my cool. So I feel really bad. And, I'm glad that we have internet and I hope I sound good right now.
it's fantastic. And you've got some fantastic pipes. You and Alabama, James, with those pipes.
No. The two best pipes, James, Morgan Palmer.
Okay, agreed.
And Cameron. These two guys, have the best pipes in the weather enterprise, no doubt about it.
And great hair too.
Thank you.
Yeah, very good hair. Wow.
Here we go. Somebody asked me if my hair was fake, and I said, "Are you kidding? Would I buy hair that looked like this? Come on."
That's a bad-looking toupee. Yeah.
Absolutely. Well, our guest tonight is a hopefully stable bandwidth internet connection with Dr. Cameron Nixon, who is a meteorologist in Norman. And Cameron, what agency are you with? And just kind of walk us through your career in meteorology, what got you interested in it, where you went to school, and how you ended up in Norman.
Yeah, so that's a really good question. I get asked this all the time by people in my building. I work with the SPC I'm funded by CIRO, the Cooperative Institute for Severe Weather, et cetera. I forget the acronym sometimes, but yeah. So that's the OU part of the whole thing. So I'm basically doing kind of like I could sum it as some like data analysis and using past data sets to better understand which parameters are most useful in what scenarios. I'm particularly right now focusing on, like we've been dealing with the whole significant tornado versus, weak tornado or significant hail versus small hail. And I'm trying to like better dissect kind of the bins from like our very small hail to our medium-sized hail to our very large, and see if there's any more data that we could find in there. I'm a early graduate of Valparaiso University. That was my bachelor's. I went to Texas Tech after that for my master's. Did a little bit of work on lightning, and then also got to drive the KA band radars for a summer. That was fun. And then went to Central Michigan University. So I've really been kind of bouncing around. And Central was for 4 years, did my PhD there, and then I'm here.
Awesome. Now, tell me about your research. You kind of got into it a little bit there.
Yeah.
You have done some really cool stuff with hodographs, and we probably ought to start from the beginning. Walk us through what a hodograph even is.
Okay, so this is actually a question that I got wrong in my proposal defense. And Matt Bunkers was right there to help show me the way. So interestingly, a hodograph is a plot of the vertical wind shear vector with height. You could say it's the plot of the wind with height, but once you kind of connect the dots, right, you'll have a wind at the surface, you'll have a wind at 1 kilometer, 2 kilometers, 3 kilometers. And once you connect all those dots, those lines that connect the dots are the shear vectors. So it is a plot of not the wind, but the wind shear vector. And man, this was back in 2018, I believe. I was at it's called the Texas Weather Conference. I think it was down in the Dallas area, Arlington. And oddly enough, I was hearing a meteorologist from the NWS Lubbock giving a talk on deviant tornadoes in their CWA and how what the kind of environments are associated with those. And they kind of honed in on this photograph, and that was, back then just something that I had heard about a few times in undergrad and a little bit of masters, and I didn't really know like exactly what it did other than SRH and bulk shear and stuff like that. And that was my gateway drug. That was a project that they had, just thrown out in the open. Hey, like we're trying to predict tornadoes that change directions. That's really cool. And so I got really into it. And that's when my brain started turning and just hasn't shut off since then.
So your brain photograph is showing high shear too.
Yes, it is.
So deviant motion on a tornado from a photograph, and if for a lot of people that look at forecast soundings, the photograph's usually up, at least with the Sharpie soundings in the upper right-hand corner of the screen. It's the little
Yeah.
bullseye looking thing, but there's a
Yeah.
wealth of information in there to determine. So what are you looking at when you're looking at deviant motion? And tell us what deviant motion in a tornado is. Give us some examples of that.
Yeah, for sure. Well, like you've probably heard like anecdotally, oh, the tornado's motion is erratic or it suddenly changed directions, and that's fortunately something that's relatively rare in operations. I've noticed at least, but could present a significant problem, especially with a longer lived tornado that happens to deviate, and now you're kind of walking out of the warning polygon. And it's primarily an issue for warning forecasters, drawing up those warnings, making sure that everyone in that warning is safe and has the warning. Um, and so sometimes these tornadoes, what they appear to do is kind of detach from their parent storm. All the information that the meteorologists have, that the broadcast mutts have, is the storm motion, the motion of the supercell storm that spawned that tornado. And occasionally these tornadoes kind of decide to just leave their parent and go their own way. And just kind of they usually head north. That's the classic deviant direction. And until recently, we really haven't understood why it's north. We're just like, okay, most tornadoes turn left or they turn north at the end of their life. And that's just something that we're expected to anticipate. And it only happens in some occasions and not others. So how the heck are we supposed to work with that? So that is where the hodograph comes into play. And what we discovered in this project, we looked at probably 125 to 150 cases of deviant tornadoes. Most of them were across the Great Plains, especially Oklahoma and Kansas.
Oh, good.
And yeah, right. And oddly enough, even though we have such a huge hotspot of tornadoes down in the southeast, I know James Spann would agree with that, not as many of those tornadoes are as highly deviant down there. They tend to take these straight paths. So what we notice is this deviant activity is strongly related to the low-level jet. And that once these tornadoes detach from their parent supercell, they tend to ride the strong winds of the low-level jet northward, which is why we kept seeing all these tornadoes pulled northward. You look at if you just do a Google search on like the paths of like the Greensburg tornado family, all those tornadoes, it's like they're magnetically attracted to the northward direction, and that was just a red flag. I'm like, there is something here.
That's fascinating.
That's-
And when I think back to the Cole tornado day
Oh,
in
yeah.
2023 in Rick's area, that to me is the biggest example of these deviant motions because I think every tornado did that.
Yeah. And that's where we get into some of my new stuff, because not only did you have the background synoptic pattern for deviant tornadoes with that raging low-level jet that day. But you also had supercells literally carouseling around each other and doing all sorts of things. So like that was just an amplifying factor. I know I do not envy anyone who was on the warning desk that day. That was hard, really hard. But it's a problem, and it's a rare but critical problem.
What are you looking at on those photographs? And we'll bring Rick in after this to talk a little bit more about cold night. But what are you looking at with those photographs that start setting those alarm bells off that, okay, these are going to be deviant?
Yeah, so really in a general sense, we're looking for the large humped half circle photographs, that classic plains. In the Great Plains, we tend to get these sickle-shaped quarter circle photographs. That's usually what we're looking for deviant tornadoes. And the reason for that is because the direction of the low level mean wind, so like the 0 to 1 kilometer, 0 to 500 meter wind, is at odds with the direction of storm motion, where storm motion is more easterly and then the low level jet is more northerly. So we want that difference in direction of the winds to be strong. We also want our storm motion to be slow, which is another reason why the southeast doesn't typically have highly deviant tornadoes. Because if you have a slower storm motion, this gets into like this complex geometry, but like the perceived difference in angle that your tornado travels is greater once you have a slower storm motion. Because if you picture your photograph or your storm motion way to the northeast quadrant of your photograph, a little bit of deviation in motion is not going to result in a big direction change. Whereas out in the Great Plains, a little bit of deviation can result in completely opposite directional changes. And I've seen tornadoes that start moving off to the southeast and then back off and then start moving northwest. Everything's possible given the right photograph shape.
Rick, it seems like, and my memory may be failing me, but it seems like I read in one of the messages from your office that deviant motion tornadoes were a possibility that day. Can you talk about how your office has put some of this research straight into kind of this practical use?
Yeah, I don't remember exactly that day. We've had a couple of days in the past couple of years really, where the right person's on shift and picks up on these signals and is either, thank goodness Cameron is where he is. We've had the opportunity to have him come talk to our staff. He's talked to lots of weather service offices, and if you're at a weather service office and Cameron hasn't talked to your meteorologist, I highly recommend it. So it will create some business for you here. But no, I think it is. I think one of the great things about what Cameron's doing is it is very practical information. It may be difficult in the heat of battle during real time. The warning forecaster can't possibly be, if they're doing their job as a warning forecaster, they can't possibly be analyzing photographs and looking at even the mesoscale environment. And that's why we always try to have someone doing mesoanalysis. So if I remember right, the cold day, that this is April 19th, 2023. There was multiple cold days that year. We got to keep all that straight. But poor Cole, they got it that year. I mean, I do remember that there were some signs, and early in the event, people were still caught by surprise. I will freely admit I was caught by surprise because due to an unusual set of circumstances, I kind of got trapped at home for the bulk of that event. I wasn't even in the office. I came home to take care of something really quick. And then the storms, number one, developed earlier than I was anticipating, and most of us were anticipating. They intensified much quicker than I anticipated. And then they were just outside the door here. And the cold tornado, as it took that deviant path straight north, had it kept going another mile, had it crossed Highway 9, it would have been right outside the door here. So I wasn't fully up on that. So I remember being on my neighborhood Facebook page going, nah, the tornado south of us, it's not coming anywhere near us until Then I looked at a radar and was like, oh my gosh, I completely lost situational awareness. Um, and the same thing happened that day with the Shawnee tornado. The Shawnee tornado exhibited similar behavior. Not all the tornadoes that day were doing it, but Shawnee and Cole, if I'm remembering correctly, really did. And I know we actually went out to Shawnee several weeks after and talked to their spotter group about it because we've experienced a couple of events like this, and to some it's like, how in the world did that happen? Tornadoes don't do that. Tornadoes, we talk about it in some of our spotter training, the classic occluding tornado that kind of, like Cameron was saying, kind of curves to the north. And that's not that unusual of a scenario, but encountering it in real life had a whole different, it's a whole different thing when you're out there and you're out of position because the tornado did something squirrely. So I can't even remember what your original question was, but the Cameron's information that he's able to convey and the kind of the system he has and the way that he has to look at photographs and to look at things, it does make it possible and a little bit easier, depending on the situation, to kind of identify these situations or at least have some sense that it could happen. So, and that's something I don't think we really had just 2 or 3 years ago. I think this is new and this is very practical and very helpful. So it did help us on that cold day, the first cold day.
Yeah, I think you hit it on the head. Like it's sort of are the conditions right for this to potentially happen? And as you noted, like these storms can show their cards early. And as soon as you start seeing deviant tornadoes, that should be, ding, ding, ding. Like this is going to be a trend that could continue. Like you said, not every tornado did that, but a lot of them did. And but once a storm shows its hand, like it's all downhill from there.
Yeah, and we did see that, and I think Vivek Mohali was one of the
Yeah.
main warning forecasters that day,
Yeah.
and he had his hands full because not only did we have storms just moving toward the northeast, and then all of a sudden they're moving north. We had storms moving northeast, then north. We had a storm cross out of Cleveland County into Pottawatomie County, and then came back into Cleveland County, almost a half circle. So it's,
Yeah.
but yeah, they did that day. They did kind of tip their hand a little bit early on. I mean, and so we were able to see what at least was possible, and I think that helped. I mean, the polygons were still a mess because just of the volume of storms, the close proximity of storms to each other.
Yeah.
It wasn't just deviant motion. There was all kinds of craziness going on with that day for sure.
Yeah. And I think your first point was great too. I was chasing that day, and I didn't expect more than just a pretty little LP at sunset that shriveled up and died. And I think that was included as a possibility in SPC's wording too. But they also touched on that, very conditional chance of a significant tornado, and unfortunately, that's what the reality shifted towards.
Yeah, yeah. One very challenging day for sure.
Yeah.
How are models, convective allowing models, probably our best shot? How good are they at forecast photographs compared to reality? And are they a reliable tool to forecast this transition? I mean, I assume if you're talking low-level jets, a big factor that you're talking closer to sunset or just after when this is more likely. How good are forecast soundings at this?
Yeah, so I'll drop it to Rick after this, if he has any other ideas, but I really have been impressed by how useful pretty much all models are in the days ahead because you're basically in like a synoptic regime. Unless you're like dealing with like a Kansas like triple point that depends on an outflow boundary from the night before and a lot of chaos. If you're, in the early season, especially in the Southeast or like any Great Plains like event, you generally have a pretty good idea of what your photographs are at least a few days in advance. And so that's something that could at least, tip your thinking toward one direction or another. Obviously, tornadoes cannot really reliably be predicted until at least, just a day or so in advance. But yeah, this is such a niche problem at this point. But just in general, yeah, photographs are pretty reliable. I guess the fun comes when you're comparing, say, like wrap photographs with like NAM photographs and different models. I know the NAM is very generous with their half circles, and the wrap is very it kind of poo-poos photographs very frequently. You just get these little straight things, and that rarely happens. I would actually say usually the wrap is a little bit less enthusiastic about photographs than reality, and then they might be a little bit closer to the name.
How
That's
about
just
old? Okay. Um, when is Sharpie going to be amended to, instead of Tor and PDS Tor, to add Dev Tor, Deviant Tornado Motion down there in the corner?
I think I've seen this on someone's some OU students um concoction that they've made on yeah, I think people are playing with it. I don't necessarily like it, but maybe.
No. So what we need, James A, we need a, DTI, Deviant Tornado Index, and Dr. Nixon is going to come up with this, and he's going to make it operational, so those of us down here at this level can see that and use that. I know that's going to happen one day, right? A
So that's
composite
already
index.
happened. It exists,
Well,
and
there you.
NWS actually has a GRT place file for it. Yeah,
Well,
Wow.
when do we see this?
yeah. I don't know. I'm just grappling with how. I mean, this is not me downplaying my own work, but like, how useful is this? Like, how is this something that we should just kind of know or have access to, or like, is this only something that's going to be useful every once in a blue moon? And I think that's the reason I don't want to just come out with some like, oh, this is the Deviant Tornado Index, and like try to oversell it, because it really is useful for each office like once or twice a year.
It's like a fire
Well, it-
extinguisher. When you don't,
Yeah,
it sits over
yeah,
there, but when you need it, there's probably nothing else on Earth that is that valuable.
yeah. I'm
and
I'm
and
thinking
and
about employing this at SPC, at least putting this on our meso analysis, whatever.
and it's a tool in the toolbox, and the more tools you
Yeah,
have in that toolbox, the better off you're going to be. And I think for all of us, we go in on what should be an active day, and you brief yourself. You come in and you look at things, but time is limited. We all have limited time, and goodness, now when you do what we do, you got to deal with all the social accounts, and you're constantly bombarded leading up to these big events. But you got to just take some time and look at data. And these composite indices, no, they don't tell the whole story, but by golly, they're useful. And
yeah.
so it's just another tool in the toolbox. And I think having that available would be a really good thing on the SPC mesoanalysis page or something, so we could see it. So
Let me work on
talk
that.
to Rick Smith. He
Yeah.
Let
knows
me work on
Rick Smith knows people. He's
that.
kind of a big deal. Yeah.
It's not like you're gonna, if the DTI is 7.5 or whatever the bad number is,
Right.
it's not like you're gonna start drawing crazy polygons. I mean,
Yeah.
it's
Yeah.
it puts this in the back of your head that, okay, well, the environment is there where this could happen, and you're going to be much more diligent about, hopefully much more diligent about watching for the signs of that happening. And
Yeah.
yeah, so I think it could be
Yeah, I've
could be
just been
helpful.
debating like my messaging between a parameter or just being in general, hey, look for humped photographs, look for those big half circles. And I don't know. I don't know what would be more effective, and this could be something we talk about, tomorrow.
Well, I want to move on to hail because that's
Yeah.
your stuff with hail is really cool too. But I've got one more question. And again, this is going from academia into practical use, especially for broadcast. But if you've got an audience of broadcast meteorologists, well, first of all, my apology if that's your audience. But what do you, what do we need to know um, in the back of our mind on severe weather, on tornado days, when we're dealing with the potential for deviant motion beforehand, and then we're drawing tracks or warning people? I mean, it goes probably the messaging's probably more than the polygon, but it's we're having to couch what the National Weather Service is saying in their warning with even more perspective and and guidance that way. What would you tell us?
Is this a question for me? For
Yep,
Rick?
both of you. Why not?
I I mean, I cannot speak more toward the community aspect and the social vulnerability aspect as much as other people probably could. The one thing I'm most concerned about for this whole ideology is the upcoming paradigm change to a probabilistic warning cone kind of approach. I know the warn on forecast problem and phi, the probabilistic hazard, basically instead of a yes or no, are you under a warning or are you not under a warning? We're moving toward a what is the probability that we see a tornado? And you could be on the fringes and have lower probability or in the center and have higher. And I think that's going to pose some issues when in the rare case that deviant tornadoes do happen. We need to know how to adjust the probabilities maybe further north, right? Like if we have a potential deviant tornadic environment, we increase our odds of a tornado happening further north than expected. Otherwise, this is something that we'll have to undergo rigorous testing. This is me kind of just spouting off.
Rick, if you had the room full of broadcast TV meteorologists, again, I would apologize for that. But what would you tell them? What do you need them to know?
About
Oh gosh, that is kind of an open-ended question, isn't it?
there's a
Yeah,
lot. We can,
This could go right down the tubes.
yeah.
I mean, about deviant tornado motion. We'll keep it in that box for now.
I mean, it's just, I think just having awareness that, that this is, I think the more we study it and the more we look at it, and we're going to have to come up with a different name because it's not as deviant as, it's deviant to some extent, but maybe it's not as deviant as we think. Maybe there's, you know what I'm saying? Like, we're always hearing like the tornado did this rare thing. Well, the more you see it, it's not really that rare, but
it's rare because of our normalcy bias.
Yeah, exactly. But I think just having the awareness, and haven't told Cameron this yet, but I really want to have Cameron come to our next media workshop that we do and talk about all of this, the hail, the deviant motion, the nudgers, all of that.
Yeah.
Just because there's so much during severe weather coverage with the TV meteorologists, it's just they're in the radar, and it's just so important to just be aware. I think awareness is key, that these things can happen. And I think some of the hail stuff, and I think some of the other stuff about the storm interactions, mergers, constructive, destructive interference, things like that. I think that would be really eye-opening, some of that, because when I saw the last presentation you did for us, it was really eye-opening. It was like, wow, it's a different perspective. So just you don't have to know all the intricate details of the science like Cameron does, but just know that it's possible. There's things that we can sometimes see to give us a heads up that it might happen, and then what you do with it at that point is kind of where that's the most important part, really.
Yeah. And Rick, I'm actually in the process of making a presentation for the National Storm Chaser Summit. So I will have something to present there at your media workshop as well. So
cool.
I wanted to ask about that because we've got so many people in the field now. And this is dangerous. Cameron, you go out in the field. I mean, goodness gracious. I mean, I think this information for this chasers in the field, especially those that are inexperienced, it's crucial because somebody's going to get hurt out here one day.
Yeah, I actually have been pretty impressed with what I perceive to be potentially this helping because I've noted over the last couple of years it's just the inevitable exponential increase in storm chasers and their proximity to tornadoes. And it really seems like, man, what was it? 2021 was a really bad year, and now it's kind of just like leveled off. We had tornadoes or chasers hit by tornadoes, it seemed like every week. And I really haven't heard of anything since, and we've had a pretty nasty year for tornadoes. So I think they're catching on, and like I've been hearing just some some whispers through social media that it may or may not be useful, and that's all I care about. I just, any one less person to go north of a tornado is a win in my book.
Yeah. And Cameron, you were there. Yeah, you were there at the Chaser Summit this
Yeah.
past year, and Skip Talbot's
Not this
presentation.
past year. No, I missed
No,
it.
yeah, about the story of the two groups of chasers in Illinois or Iowa. I can't remember where, but it's all online. You can go on YouTube and find it. But yeah, that's a direct application of some of this,
Yes.
as far as situational awareness. And so yeah, I hope you're right about that, because yeah, 2021 it did literally seem like every chase event something was happening like that. But it's,
Yeah.
yeah, knock on wood, knock on
Yeah.
wood.
Let me ask you, and Rick put the ball on the tee perfectly for it. Nudgers and mergers, destructive and destructive. Very rarely do we have these lone supercells rolling down, putting classic tornadoes down. It's a lot messier than that. Talk a little bit about this research you're doing, and again, we're seeing this take place with National Weather Service offices being aware of, okay, this is going to be a constructive merger. This is going to help spin up a tornado, or this will likely end the tornado. And the one that I'm thinking of that we talked about when we had you on before was the one in Hot Springs Village in central Arkansas earlier this
Yes.
year.
Yeah.
Walk us through this merger thing and how it is, well, to use your words, destructive or not.
Yeah. So this is where all the goodies were lost in the ether last week when we tried to do this. Um, yeah, so this whole project came about as my response to this constant aggravation over environmental data. Because you could pour through soundings, you could do statistical studies, you see the low-level shear strengthens as tornadoes strengthen. You see that larger hail is associated with stronger cape, etc. But there's just such a wide range in potential environments that lead to these. And so I was just sitting there like, okay, what if there's more to be seen in kind of the near storm scale that we're not seeing in the environment? Maybe something in the radar, at least what we can perceive with radar data, is preconditioning a storm's local environment in a way that, Cape and bulk shear cannot tell us on the broad scale. So I didn't really think much of it going into it. I just figured, hey, I'll find like more tornadoes or more hail are associated with cell mergers. Maybe like cell mergers are a good thing, what have you. I ended up finding a lot more nuance than that. And I really, what is ingrained in our heads from school is that supercells produce tornadoes, and their production of tornadoes depends on the background environment and the wind shear and cape and etc. And that discrete supercells have the highest potential of producing the most significant hazards. There can be a lot of different ways to define discrete. There's isolated, discrete. It gets into the semantics, but generally, when you're thinking a discrete supercell, you're thinking a supercell that is kind of by itself, not part of a line or not part of a cluster, what have you. And we overwhelmingly found that when we looked at cases of intense tornadoes, EF3 and greater, and then very large hail, 3 inches and greater, overwhelmingly, these supercells had something else significant going on while they were producing the tornado, or just before they were producing the tornado. It was not just a supercell just frolicking happily through an open worm sector producing a tornado. That was very rare. It was at best, a supercell that got impacted by another cell. At worst, a supercell that was just part of this immense, messy cluster with boundaries and all sorts of things going on. So, I think one of the most important kind of conceptual ideas that we found was that we've been keyed in on these cell mergers, right? Like more cells coming together, creating a bigger storm. And honestly, those were quite common in cases of intense tornadoes and very large hail. But especially for tornadoes, there was a lot more that could kickstart that process. It was not just your classic merger. It was maybe a cell that kind of approached it from the rear really slowly. Maybe had like like kind of a glancing blow, or maybe there is like a line or something that collided with that supercell really suddenly. Or yeah, it could get really subtle. Some of these, we called them nudgers, the really subtle things, because they don't kind of merge into the storm and become a new storm. We might just have a supercell here, and then a nudger just kind of slowly nudges in, and that nudge, that downdraft that cell creates, basically enhances the supercell's RFD. You wrap up, and then you produce a tornado. And so a lot of it has to deal with rear flank downdraft dynamics. And what is the rear flank downdraft? Is it something the supercell makes itself, or is it something that other cells create when they smack into the supercell? Yeah, there's a lot there. There's a lot there.
What makes something nudge it stronger or weaken it? I mean, so what I think I'm hearing is that when there is an interaction, expect a change in what that storm's doing, whether it's
Yes.
good or bad.
Yep. That is another key conceptual point to this, is that I like to tell chasers, it's not just your storm. It's not just your supercell. It's all the other storms in proximity that could also impact that supercell. They could collide with it really suddenly and really strongly. They could just kind of tap it. They could just be hanging around it. We need to start looking at the cells, and in our study, we looked at kind of a 25-kilometer radius, so decently far from these storms. We need to start looking at all the array of cells that are in that supercell's playing field, because they all seem to affect them somehow. So yeah, and now here comes the inevitable, is a nudge good? When is a nudge good? When is a nudge bad? When is it constructive, destructive? And unfortunately, all I can tell you is that it depends. It depends on a lot of things. It depends on its position relative to the supercell. Basically, we found that if you want to use the words constructive or destructive, I don't actually like using those, because it depends on what hazard you're producing. If you have, say you have a supercell and you have a cell that pops up in its rear flank, that can be constructive. That cell in the supercell's rear flank can enhance its RFD, help that RFD surge and spin up a tornado. Whereas a cell in the forward flank can actually, my hypothesis here, given the data that we have, is that these cells in the forward flank of a supercell can momentarily stabilize that storm. The precip and downdrafts that cell is dropping in the forward flank can get ingested by that supercell. That stable air is ingested, and we kind of hold off tornado genesis for a bit. Likewise, I don't like using constructive or destructive, because a cell in the forward flank of a supercell tends to enhance hail production. And hail is a process that could potentially be assisted by low-level stability, which is very counterintuitive. But all sorts of things. Generally, forward flank is bad, rear flank is good if you want tornadoes. And the opposite seems to be true for hail.
Wow.
Cameron, I know you've been out chasing, and I'm sure you are. Are you thinking about this stuff when you're out chasing? Are you
All the time.
watching for these things there from the ground when you're actually out there versus just on radar? Have you seen anything in the field this past season or recently that applies to this or plays into any of this at all?
Absolutely. I'll give two examples. My favorite tornado intercept this year was down near Duke, Gold, El Dorado. And that was just absolutely classic. You had a beautiful merging of like three different supercells into one. As soon as that merging happened, you just had a raging downdraft. Your hook echo bounced out and whatever. Just absolutely classic. Another one was just a week or so ago. We were up in Nebraska, And we're dealing with a supercell that was at the tail end of kind of this messy cluster. And presumably then, that supercell had storms that were in its forward flank, kind of stabilizing its inflow. And so we watched this storm try and try and try and try to produce a tornado. And finally, like, right before we almost left it, it produced this really tiny little needle sink drain kind of thing that lasted, 5 minutes and then bounced right back up. And I think that's, again, just an anecdote, but kind of how these things work. You're looking for what is our array of cells around that supercell? What could they potentially do? And I wasn't super optimistic seeing all those cells in the forward flank of that supercell in Nebraska, but I ended up being surprised and I had fun with that. So
Wow. Rick, how has this changed what y'all do in the office? Or has it?
I I don't know. I mean, I don't know that it's changed. I mean, we've always kind of been on the lookout for these interactions or these mergers. Quite honestly, a lot of the time, there was not a lot until, I mean, Cameron gave us some things to look for, but up until just recently, there was like, well, we'll see what happens when this storm intersect, when there's something coming up from the south that's going to crash into the inflow area of this big supercell. We think this might happen, but it's just kind of a wait and see. So it's still that way to some extent because, like Cameron alluded to, there's so many variables, the exact angle of attack and angle of that they're intersecting, and knowing the quality of I mean, you don't really, there's things you don't know for sure about the storms, even if it looks like there's a lot of outflow. I don't know. There's a lot of variables. So I think we have more that we can use now to make a better, more than an educated guess, but still a lot of times it's like, well, this will be interesting. Let's see what this does.
and that's me too in the field. Like I have a general idea, but every interaction is different. And I think you said something, so someone in your office said something that stood out to me, and this is I guess a positive feedback that I've gotten every time I've given this talk, but like they basically said like you didn't teach us anything new. Like you just show like I feel like I'm showing people a blueprint of what these things actually do, and every time people are like, oh yeah, I've seen this do that. I've seen this do that. And like it makes perfect sense now that I kind of give it in an orderly fashion, but y'all have seen it every day.
It's just that perspective and that different way of
Yeah.
kind of stepping back and looking at it a different way. That can be huge. And so yeah,
Yeah.
it's things we've been looking at for decades, but it's like,
Right.
oh,
Right.
so that's
There's
why
an
it
order
did
to
that.
it.
Yeah, yeah.
Yeah.
But that's kind of, we've seen it a few times. Now we're starting to understand why what we have seen
Yeah.
actually matters in this.
I think so.
Um, TV folks, again, hate to have the uncertainty while they're doing this. We see the blips getting closer and want to say, this is what's going to happen.
Yeah.
But we don't know until we know. And that's a really dumb way of putting it. But I
Yeah.
guess we don't know until we know, right?
Yeah. I think we finally, so where I think this is truly important is that as forecast or as warning forecasters and broadcasters in a tornadic situation, the only data that you have is the strength of the storm and its mesocyclone and its hook echo and other features of the storm itself pre-tornado. And I think where other cells come in is maybe you have a little bit more lead time. Maybe you see that cell approaching from the rear and say, okay, I can't say this is going to cause a tornado, but it might heighten the probability. It might increase the storm's mesocyclone. It might, initiate that RFD surge. Now we're the slow ramp up other than hey, it's tornado time. So we have a
And
little
that's
bit more.
perfect material for like NWS chat. I mean,
Yeah,
that's exactly
absolutely.
where that really comes into play. It's just like this is what we're watching. This could happen or this could happen. We believe
Yeah.
we're leaning more toward this happening, but let's see.
Yeah. Kim, you had some awesome questions last time, and I'm so sorry for what happened. So yeah, let me hear
Yeah, I'm so sorry. Can you guys hear me okay? Or am I the terrible one this time?
No,
Loud
I
and
can hear
clear
you.
from
Oh,
Wellington,
great.
Texas.
So it's funny. I'm driving now for our listening audience, for your benefit. Everybody got to see me join by seeing the roof of my car. I've been listening to the YouTube stream, so I've been following the conversation, but I just had to try again to join in. We're so excited to have you back. I think
Thank you.
the question, one of the questions that I asked last time, I think would be great to bring around again as we're
Yes.
having this conversation about operations. You're right. It is so much our training to have these really like high cape, high shear environments. I think they give us a lot of anxiety. I mean, we have a heightened state of alarm. We're all feeling very like, oh my gosh, this could be the big day.
Yeah.
And I can only imagine what it's like being either in the SPC, putting out outlooks and watches for these and MCDs, or in the local office issuing warnings for them for individual storms. Something that I asked you about last time was, are you seeing any success in or engaging in conversations with forecasters at different levels about maybe if an environment looks like it could produce a bunch of splits and mergers, maybe tempering those expectations and allowing themselves to hold back on the trigger in issuing a warning, or maybe not issuing it, but just I don't know. I don't even know how. I don't think I'm asking this nearly as elegantly as last time because I'm driving. But I can only imagine how difficult it is to stare high cape, high shear in the face and to
Yes.
say, nope, I'm going to hold back on that.
Yeah. Yeah. I mean, I know that that's probably inspired by this year in Oklahoma, where, they ended up verifying, but at what cost? Like, I mean, the entire early show was just some kind of failure mode. Um, yeah. And like, that's so in short, I think I've gotten the most positive feedback from NWS offices, who actually look at radar in an intensive way every day that these happen. Um, I think this project is too new to really have a huge impact on the way we issue warnings, and I personally wouldn't want it to, unless we know a little bit more. I think there's a lot to learn about the background environment and maybe what high cape and high shear are doing to make these interactions more or less common or more or less favorable, because it seems like the same interaction can do different things on like a high cape day versus like a low cape day, or a high shear versus a low shear. So that's something that I think we still need to work out before we really use this daily in operations. I had another part to your question, but I think I lost it. Otherwise, I one thing that is fascinating me now is, after seeing these stretch of moderate and higher risk days just not pan out the way they were anticipated until much later. I think the failure mode aspect of this and potentially destructive interactions is really fascinating, and I think we need to look at those in a lot more detail.
Yeah, I appreciate that. That's so what I'm thinking for the future of this too. Looking on, this whole season, trying to just think about the challenge facing, especially SPC,
Yeah.
since my focus is the national centers. I just couldn't help but think, well, what does the system lend itself to forecasters being able to articulate that there are multiple possible outcomes? And the way that we've set up the outlook, it's really here's like the most likely outcome. But we even know with high risk days, with those kinds of environments, they are prone to different kinds of failure modes. And I think we all know that internally, but we haven't found great ways to describe that. And in some conversations with different severe weather scientists, forecasters, one of the things that they've admitted is it really are still being state of the science. It's not always the case that they could have specified ahead of time something that was a particular fail mode.
Yeah.
And so it's not just specifying, hey, here's the full array of possibilities. It's actually a little bit more like, hey, we have some really serious ambiguity here. And that's a different kind of animal to try to convey to people. It's not saying we know that here's outcome A or outcome B, this is what it's going to be. It's more, man, this is a volatile, shaky situation, and we think that it could bear out this way, but if it doesn't, there's things that happen that are still beyond our ability to forecast, and even in the short term completely understand. So it's a communication challenge that's pretty profound, isn't it?
Yeah, and what Rick just said in the chat, right? You never want to backpedal on a day with an environment that is that potent. Like our high risk days, like our couple moderate risk days. You never want to really backpedal on that unless you have, overwhelming information. And I think that's where, I know that internally we're moving toward a better way to differentiate between probability and intensity. And maybe we can better make use of these, maybe if cams or if our intuition are showing that storm interactions might be really messy, like our I think that was a high risk day. I'm getting them all confused, but that day where there's a lot of chaos and left movers expected, maybe you lower the probabilities on that day, but keep your intensities high, because those are the environments that produce significant long track tornadoes.
Yes, definitely. And if you guys will indulge me, at least just one more quick question
Yeah,
in
please.
here. Sorry, as I continue to just drive merrily down the highway. Now I know what this was like for you last time. Yeah, and it is fun. Actually, I'm about to drive into Joplin. I'm on my way to
Oh.
Kansas City. A quick question on the way to my final question. Recalling the Joplin event, is that one that you had reviewed by chance? I believe that was a cell merger case, was it not?
Absolutely. Yeah, there was a really fun array of interactions preceding that. Like the mesocyclone that produced a tornado basically like handed off from one supercell to another. And yeah, there's lots going on there.
Yeah.
Really good example of a supercell that wasn't discrete, that was actually really messy, produced one of the most violent tornadoes that we know.
Yeah, I loved the conversation about what is discrete versus not discrete, and that leads me to my last question.
Yeah.
And I know you've been in and out of the hazardous weather test bed. I don't know if you've gotten to see the probabilistic hazard information tool, the FEE tool.
Yes, not like actively.
Yeah. Well, I'm curious what you think about something, if you all can still hear me. I feel like I'm getting choppy.
No, I can hear you.
Okay, great. So one of the things that happens with the FEE tool is a forecaster, there's either automated guidance that sort of circles a storm object, or a forecaster can circle like a storm object. And what tends to happen is with like multiple storms in a line or a cluster, forecasters will make a whole bunch of little objects, and they'll put out a probability plume for each one.
Yep.
And with the case of mergers going on, it complicates in my mind a little bit what actually is a storm object, and how should we be thinking about, in a world where all these mergers happen, is this something where you're thinking about maybe a climatology, or just showcasing how often this is a problem, and that maybe we should think a little bit more expansively about what even is storm. And
Yes.
I don't know. I just see this as another question.
Yes, no, this is something that I have banged my head over many times. Lots of fun reviewer comments on how we differentiate between, what is a storm, what is its centroid, what is I mean, there's definitely a few different things going on. There is a storm's downdraft. There is a storm's broad mid-level mesocyclone, and there is a storm's tornado cyclone. And it seems like all of those things can kind of bounce from storm to storm, or like be inherited by other storms, or it's nuts. And like I agree. I think we need kind of a climate a broader climatology, especially with like our weaker tornadoes too, of like how common are these things? What should we make our storm objects? I know internally through NSSL and SPC, where Matt Flournoy is heading his supercell database, and we have a lot of tracks of supercell storms. I don't know exactly if mergers and other cells are really in the cards for that, but that would be pretty cool. Did I answer your question?
Yes, you totally did. Thank you
Okay.
very much.
Yeah.
Kim, Troy here, and Cameron, thanks for coming back and seeing
Yeah.
us
Thank you.
after a couple of weeks ago. But Kim, I want to throw something your way, and Cameron as well, and the panel as well. Here we are talking about essentially multiple solutions, and we understand that the atmosphere can change its mind, and that storms can be hybrids and things like that. Kim, how in the heck do we communicate that to the public? Because this spring has been a test. You've had people calling weather service every name of the books. It didn't verify. It's a blown day. Well, it wasn't. It wasn't what they expected. But my question, Kim, is how we do that, or Cameron, how do we do this? Rick, how do we message this where there are multiple solutions possible? I don't know that we can.
I'll let Kim
Well, yeah, I'll start by saying I'm a little more optimistic that we can and that we should. And that's kind of what I was hinting at earlier, just thinking about our Outlook system. And Cameron really nicely covered how SPC is working intently to think about another way to peel apart from intensity, between intensity and coverage. And taking things back to decision science, informed decision making, the work that's been done on it in other contexts points to the importance of helping people understand that the multiple outcomes that they could experience and how likely they are, so that they can make a decision between the two. So in medicine, it's really important if someone might face a procedure, you can give them, the uncertainty of there might be observational uncertainty to take care of first, right? And they have to weigh that against like the probability of detection, false alarm thing, right? Against what the treatment might be. And so, treatments often come with their own side effects and their own, costs. And so if you're going to weigh the decision to pursue a treatment or not, you really have to understand, well, how likely is it that this thing really does exist, that we've had a correct detection, and what are my possible losses, or what do I face in consequences if I get treated or not treated. So the similar case can be made in meteorology, that it would be really useful to let people know, maybe the most likely thing is this kind of scenario, but there's maybe a lesser chance, but still important to say that nothing may happen at all. And it helps to communicate forecast uncertainty. Part of it is it's trust building. I think a lot of people know that we have uncertainty even on those high risk days, and they're experiencing it. And if we don't say transparently, we know this could be a day where, all kinds of things could happen. One high risk is not the same as another. There's a difference that we could be talking about. Then they don't have a basis to understand what happened and why. And, they're not as inclined to trust us as if we were able to give them a little bit of that context. So, these are things that sometimes end up buried in discussions. It's not like they go undiscussed amongst our community. It's a question of how that ends up getting out to everybody else. And it's really natural for us to fixate on worst case scenarios and upper bound estimates, and to be very concerned when something could be a very bad event. We want people to be prepared. And so it's very natural to really focus on that as a way of thinking about motivating people to prepare. I think it's a surprising finding for a lot of people that the social science research does find perhaps a more conservative approach where you're just offering a little bit more of that information actually tends to help people to prepare better, and because they trust you more. And, that's what's really important. So that's my answer to your question, Troy.
Well, and I didn't mean to imply that the Weather Service and Storm Prediction Center and the local offices, Norman, Rick, and others don't do a good job in doing that, because they do what we're talking about, but addressing that the general public. That's sort of where because I think if people are in a high risk area, they expect they expect their tornado. Or they expect their severe weather, and more than likely they're not going to get that severe weather or that tornado. So I don't know. I just wonder how, and especially that there's a special place. There will be a special place in history about the public understanding these sort of things in 2024, because either it's a blown forecast or it was good. In 2024, there's little in between anything these days as far as arguments and that sort of thing. So I don't know. It's just been, I think, a rough spring for the Weather Service, not because they've done a bad job, the public's giving them hell.
And I will jump in and say, Troy, I think part of the issue, and again, please understand this is not a blanket indictment of YouTubers and TikTokers. It's not. Mm-hmm. But there's a lot of bad actors over there.
Yep.
And they hype these things up to extreme levels.
Thank
you. People hear the TikTokers and the YouTubers, and ultimately they don't even listen to the voices of the Weather Service or professional meteorologists. And when a tornado doesn't come down their street and they've been hearing death, doom, and destruction for 5 days off the TikTokers, then they get mad at the Weather Service, at SPC and the local offices. And again, that's just a problem. And that horse is out of the barn, and it's not going to go back in the barn.
Right.
And there's nothing we can do about it. But I do, and I think somebody mentioned this in the chat, maybe Rick, with winter storms. I like to do, this is the worst case scenario, best case scenario, and the most likely scenario. Give them three. When I brief football coaches, this is what I do. When I brief college football coaches, baseball coaches, whatever, I give them those three things: most likely, and then the best case scenario, worst case scenario for the outcome here. And so I do think it's a matter of expressing uncertainty, but we've got to cut through the noise and be better at reaching people. And we have to stay relevant. And, doing that, you got to change with the times, and we have to change with the times to communicate with people.
But the noise is part of being entertained. And as a society, man, we clamor to be entertained more than anything else.
Yes, the people, they flock to that. And, all this is a Kim question. I don't want to make Kim run off the road somewhere. She's out there in Southwest Missouri, trying to drive and listen to all this nonsense here. But most of this is a social science thing. It goes beyond physical science. And sorry, Kim, if you run off the road, I apologize. Please don't.
No,
run off the road close to Fred and Red's in Joplin. That's some good chili.
Yeah, actually, I just got off of the highway and I'm on Rangeline Road in Joplin. So it didn't really run off the road. I very gently pulled over onto a very, very nice road. I love that I'm giving you guys updates. I feel kind of like a chaser. The only thing I'm observing is the very calm sunset. But it is kind of weird feeling talking about this right now as I'm literally crossing the damage path from the
Rangeline Road,
Joplin tornado.
Kim, that's right there. You're right in where the path was. Yeah.
Yep. This is where it went. So anyway, yeah, I wish I could give you more solid ground to make very specific decisions about how to architect the communication system. I think we're still at the stage in our social science knowledge where we're still wrapping our brains around this too. I was having a conversation with some colleagues at like Weather Service headquarters, social scientists there, and social scientists at GSL, the lab in Boulder, and we were talking about this issue of communicating forecast uncertainty and how it has been so challenging to pull together the literature that does exist so far to help make sense for forecasters, because there's this desire to just say, okay, give us what categories we need, what colors we need, like how do I need to say this? And we are back at this square of what are you trying to say? There's so many different ways to express uncertainty in a forecast because the forecast has so many attributes, especially when you consider space and time. And that is just so much harder than any other discipline that we can think of that has looked at this problem of, communicating uncertainty. Even the public health example I drew earlier, it's a little bit more straightforward because it doesn't have that just like very rapid change going on, and that spatial interpretation piece, that it's happening to your body, and it's, X will happen or Y will happen. It's just, we are in a tough spot. While these are social science questions, they're also things that the field is going to have to feel their way through a little bit, while we're also finding a way to do research that will address the question with you. If there's anything that people listening to this show have come to understand, I hope it's that we're not, the social science, we can offer you a lot in how to think through your problems. And I think we still need to work alongside you a whole lot still to get the answers, to frame those questions really well so that we can get you answers that you need, and not just the quick, easy, but maybe not quite hitting the issue answer.
There's your answer, Troy.
Yeah, and I just think, and I agree completely with what James said and everywhere else. But again, and Kim and I were last week at this time with the broadcasters and with the communications folks, the AMS meeting over in Myrtle Beach. And when it got down to probability, we found out what the public understands about that, which is about the goose egg. As far as probability, how do you state probability to the public? And how do you state uncertainty, as Kim said? So it is what it is.
And I think it's, one of the questions in there too is even how close does a tornado have to be for me to think it was a good forecast?
Yeah.
If I'm in Tulsa and Barnsdall has a tornado on a moderate or high risk day with a tornado watch, do I still think that that's a successful forecast and watch? I don't know the answer to that. And maybe everybody perceives that differently.
Yeah.
And if that's the case, woo, best of luck to us all.
I would argue, I don't know this and don't know what I speak, but the bottom line, I would figure if someone saw a tornado, they would say, okay, there's that tornado they forecast, but that's not going to happen most of the time. So I don't know.
Yeah, I'll add a little complication. Yeah. I'm sorry. Okay, James, you just raised something that's one of my favorite problems. We think about space and distance very, literally and linearly in our field, but my home discipline, geography, we know, and I've actually measured psychometrically, the perception of distance can change based on sort of one's connection to a place. And people do perceive boundaries on the surface as being really material when they're going to interpret their risk. So, for example, one of my favorite but also most daunting pieces of research has been place-based perception of risk from tornadoes. In Oklahoma, you can go from one community to the next, and they have very different views on the risk proneness, and that corresponds to a distinction that they make when we do have a high risk day. There are people in some communities that are much more worried and preparing than others because it doesn't apply to them. Or, as they're watching coverage, they, like people I've interviewed in cities, they are looking at a much finer grain scale to say that something is for them. And people who are in more rural areas, who are more attached to larger spaces like county boundaries, they're actually more attentive to those. So space and place aren't the same from person to person. And That does make things harder, James. It does. I don't know what to do about it yet.
I would say that's a good dissertation topic, but I think I've already about hammered one out. So
Yeah, let's just get you graduated, man.
oh my gosh. From your lips to God's ears. Yeah. Well, now that we've solved these problems, Cameron, I know we also want to talk about hail because that's what you're kind of doing
Do we
right
though?
now. Oh, we do. We do. A nice cooling ice bath would be pretty good right now in
Oh,
Oklahoma.
for sure. Yeah, and I think Kim's logic there segues really well into hail too, because hail, one thing that I'm learning as kind of a selling point on hail is the expanding bullseye, and just, our cities growing and becoming a lot more vulnerable to the massive supercell that just carousels through the DFW area.
So tell us, big, small, how do you know what's coming?
Oh man. So um essentially sorry, this was just a really wild segue from Kim's social vulnerability to hail. I'm trying to piece that together, but no, I think
Hail, yeah, it was.
yeah.
Sorry, I just gave you a second. I gave you a second.
Wow.
All your
Show
time.
title.
man.
Show
Someone had to say
title.
it.
Show
Oh,
title.
yes, it was. Yeah.
I
Thanks, Kim.
see what she did there.
Mhm.
Oh no, I've let Oklahoma James out of the bottle.
No, you trumped him. That did it. That did it.
So I think man, what my kind of message here on hail is that for decades now we've been using a very similar approach, that we haven't changed in really decades, right? We use our cape, our lapse rates, our freezing level, and our bulk shear. And those are usually the only, parameters I've seen mentioned in forecast discussions about hail. If you can think of any more, let me know. I know some savvy folks might use like CAPE in the hill growth zone or something similar. But it's generally a very simplified process, and hail is anything but that. It's what we've figured out. And I was really lucky to be on this Vil of the day. Yes, no, I don't ask me what I think about Vil or Mesh or anything in that regard. But so where was I going with this? Um, I was lucky enough to work in my PhD with a group who was funded by NSF to work on just better understanding the environments of hailstorms. And by statistical, kind of climatological or environmental approaches, that is what I did. And then there were a lot of other people who did kind of a more modeling approach. How is hail growing within the storm? How is that affected by the parameters that we use, etc.? And hail is a really complex process, and it depends a lot on the residence time that stone has within a storm. And contrary to popular belief, it's rare that a hailstone goes up to the top of the storm, then back down, then back up again, then back down, and kind of recycles. It usually kind of does like a spin lap around the mesocyclone and then falls out. Don't ask me anything more about the trajectories of hail. That is not exactly my wheelhouse. But really, this residence time problem is a lot more nuanced than just saying, hey, more cape is better, or lower freezing level, suppresses the melting of hail. Couple of the most important things that me and, my buddies in this process have found is that cape is really only good to a certain degree, and it may just be the depth that storm gets to, and how wide it is, the proportions of that storm, that are the most relevant. And in fact, it appears that too much cape can be too much cape, and the residence time of these stones may be hurt if they eject too quickly through that storm, and if the storm's updraft is too strong. So very counterintuitive. A lot of us, have the whole gravity argument, right? A larger stone needs a stronger updraft to hold it aloft. But there is kind of a Goldilocks zone. where kind of a moderate amount of cape seems best. So it seems that a moderate amount of shear seems best. Basically, there's a lot that we have to rethink.
And I presume this is not just seasonal, but I mean, not to harken back to Ville, but you get much bigger storms when the atmosphere is warmer. That I
Yes,
would assume the shorter storm is in the winter can make the same size hail as a big tall beast in June or July.
generally so. Yeah, it's a lot of where that cape is distributed. In the summertime, especially down in the southeast, you'll get these pulsy type storms with, 80-degree dew points, and most of your cape is distributed below the freezing level. And that is actually not too favorable for hail, we've found. Except for, some other circumstances, and cell mergers and all those fun things can weigh in on that too. But what we've found to be most favorable generally is a higher concentration of cape above that freezing level, or even most of your cape is just above that freezing level, kind of minimizing the buoyancy below that freezing level and maximizing it above. So and just like tornadic environments, hail environments are very diverse. They could span a lot of different, profiles. And so this is not a be all end all. It's just what we tend to see with our most prolific hailstorms. So already different than what we, kind of walked into. It's usually bigger cape is bigger hail, and that's a resounding no so far with environmental. And honestly, the range in cape almost seems to fall off as you get to larger and larger hailstones. That was one of the funnier results I found, in that most like very large hail is really confined to having like at maximum like 4,000 cape or something. So it's not your 7,000 cape days.
Well, tell us why hail estimation algorithms still aren't very good.
So do you mean like parameters or radar based?
Radar based, especially.
Ooh. So not exactly my wheelhouse, but we really just cannot rely on. I know I heard Matt Cumgen give a really good talk on the relationship between reflectivity, right, in our 60 DVZ, 65 DVZ, and hail size. And man, if only I could describe this, but he basically found there is like a relationship where past 2 inches or so, the relationship was kind of this sine wave where, oh, how do I put this into words? But like, you basically have no skill in using reflectivity past, 2 inches. And I think there's a lot to be said about new like dual pole algorithms, etc., that might help things. But he in his study he showed that mesh was really not a great way to determine hail size. And I know that, yeah, people use their Ville or Ville today, and that's mostly just like a how much precipitation is in the entire column, and we're really worried about, the amount of precip like above that freezing level. So I think there's ways that we could streamline it, but we are fundamentally limited by radar in our ability to detect big hail, and that's just, the nuts and bolts of microwave energy.
Well, that's kind of depressing.
Oh, it is. It's very depressing. So I think that really I'll plug myself now, because I think that's really a handoff to understanding the environment and understanding the storm scale interactions and favorable configurations that do lead to big hail. I think we might even have a better shot understanding our potential for big hail if we look at other things other than just, reflectivity and volume of hydrometeors. Yeah.
This might be a Kim question. The severe thunderstorm criteria, 1 inch diameter hail, is that good? Does it need to change? What do you think?
Yeah, I'm going to defer that one.
Oh man, I hate these questions because the thing is, like, man, but selecting one specific moment when a hazard matters versus not is just so fraught, because it all depends on who you are, what your structure is, what your circumstances are. I appreciate that some line needs to be drawn. And so I think, for the time being, trying to make some distinction about, well, this is where you have whatever kind of damage starts to get done. At least there's a benchmark that is just what it is. Hail, from a social science perspective, I can just really honestly say we don't know very much about how people perceive the risk from hail, what they do, if anything, in response to severe thunderstorm warnings generally. I think the work that we're seeing from surveys that ask people, like in general, what they do, not specific to any particular event in the real world, but what they think they do, they're not super enthusiastic about doing very much. So all of that tells me that I think this is just really situational, and if we can find ways to help people understand that there could be really damaging hail further ahead of time, that gives them the best chance that they could possibly have to at least try to shelter stuff and get toward indoors, knowing that is coming could help them to make some kind of decision. This is a tough one. This is a really tough one. And I'd love to know what the rest of the panelists think about that particular threshold.
Rick, what do you think?
Not to take the easy way out, but I mean, it really does depend on all those factors Kim talked about. I mean, what size hail is a problem for you personally? I mean, there's been talk, through the years off and on about regionalizing these. It's like, well, do you make different severe criteria in Connecticut than you have in Oklahoma or Florida? Or, I mean, you can only imagine it's hard enough to keep up with it as it is, but I don't know. I think it just depends on a lot of factors that we just don't know. I mean, it's very personalized, the risk and what you need to do, how long you need to do something to protect whatever you're protecting from the hail. I don't know. I mean, we have to have a number. We have to have something, like Kim said, to start with, but I don't know. That's a hard one.
One of my favorite or least favorite questions that I've been asked after the PhD is, I'm using these bulk data sets of hail reports, and to get a hail report, someone has to, make a report. And let's say there's an EF4 tornado ongoing right next door. Are you going to be hastily making that hail report? Probably not.
No, I can tell you no.
Yeah.
Hail reports fall off dramatically when we have tornadoes going on. So, yeah.
And so the fun part is, this loosely tangentially relates to the conversation we were having. I think it depends a lot on what other hazards are present. But the interesting side tangent then is that what we've been finding, the environments that are more and more favorable or supportive of tornadoes seem to be less and less favorable for hail. And even when field research teams go out and they're underneath these supercells, it seems that the hail process gets stunted or ceases or stops momentarily when a tornado starts. So there's more truth to that than just saying, hey, people don't call in the hail. But I think this all works into what other hazards do we have? Are we dealing with like a damaging wind threat alongside a hail? Because theoretically that could be a little bit more impactful. Like a 1-inch stone falling vertically might not deal as much damage as a 1-inch stone falling horizontally at 60 miles per hour. Lots to consider.
Well, in my issue here, we basically had no tornadoes all spring where we are. It was just dead.
Well lucked out.
My quiet. I've been doing this. Let's see, goodness, 46 years, and I think I would have to go back into the 80s to find a year this quiet where I am here. So, but we did have some wind events, and timely severe thunderstorm warnings were issued, and it seems as if nobody listened and nobody responded to those warnings. And so I'm trying to find out from these people why did you not listen or respond if you heard them? And most people have a weather radio or have a way of getting the warnings. And I'm not a social scientist, but it just seems like there are too many of these things, too many severe thunderstorm warnings that don't verify. And if we can issue warnings based on 1 inch hail, we really, really, really get 1 inch hail. I think it's fine. Or if you really have 58-mile-per-hour winds, but I'm seeing a lot of these warnings issued with, little pea-sized hailstones and 40, 45-mile-per-hour winds, and they don't quite verify. But anyway, it's a Kim thing. So we James A, we beat that drum to death. I'm sorry.
I know the overwarning of hail is a known issue for sure.
And it's kind of, I look at hail as a threshold, and I know there's probably not the distance that we would quibble over between what was originally 3/4 inch hail for severe thunderstorm warnings, and maybe you boost it to what, 1.25 inches, or something like that. Not much, but the impact is still the impact from hail, and it may have some variance there by size, but severe thunderstorm hazard wind is what has such an enormous difference that your 60 mile per hour wind is nothing to a person in a home, but it's everything to a person on a boat or even an unanchored mobile home too. So these are very complicated problems. But yeah, James, do you have any more? Hit Cameron with the hard questions now, and then we can go on to the recorded fun stuff.
Yeah, I know that Dr. Nixon has got to run here. We got to hit a couple of recorded segments. Cameron, if people want to follow you on social, what's the best way of doing that?
Yeah.
But this is great stuff. I mean, this is really good stuff tonight. But so they're intrigued. They want to learn more. How do they follow you?
Yeah, so really search me on Twitter at Cameron J. Nixon. You can look me up on YouTube. I'll have some kind of tutorials on that put together all my latest work on hail and storm interactions. Just search my name on YouTube. You'll find some stuff. On my website too, if you just search Cameron Nixon WordPress or Cameron Nixon storm interactions, etc., you'll find me. I'm just ranting about things online. So
I like it. I like it a lot. Well, it's been a great show. Thanks for coming back. We owe you one. This was great.
Thank you guys so
Kim wants
much.
to say something before Kim wants to say something before you leave. Go, Kim.
Oh no, Kim was just laughing at his wonderful sense of humor. But Lori, I know I was listening to YouTube earlier, but when you were talking about isolated supercells, frolicking in the warm sector, I died. So just thank you for bringing your humor tonight.
I have this very odd way of personifying everything that I see. I think that's kind of my humor.
All right. Well, Cameron, thanks again. Appreciate it. Hope you come back.
Yeah,
soon.
thank you guys. This is awesome.
Thanks, Cameron.
Y'all have a good one.
Good deal. Let's take a quick break here. We're going to hear from Tony Rice in the Astronomy Report. We've got Jen, and This Week in Tornado History. We'll come back with Picks of the Week and more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
This week, look for the moon to cozy up to Saturn, rising around midnight and reaching its highest point in the pre-dawn Thursday sky. It's also around the time that Jupiter is rising as well in the east. Saturn also enters retrograde motion this weekend. You might have heard the term in more of an astrological context, but it definitely has an astronomical one as well. This refers to the apparent reversal of a planet's movement across the night sky. This happens when the Earth overtakes a slower moving planet in its orbit around the Sun. It also happens, and more often, by the inner planets, Venus and Mercury, as they're overtaking Earth. This retrograde motion is technically apparent because planets are, of course, continuing their journey around the Sun, same direction and pretty much the same speed. 21,600 some miles per hour in the case of Saturn, which still makes for a year that lasts more than 10,700 Earth days. It's all a matter of perspective, though. You also see apparent retrograde motion each time you pass a car on the highway. You might be going 65, but if that car next to you is going any slower, and your focus is solely on it, it can look like it's moving backwards. The effect is much more apparent in the sky because the background of stars are so far away. Think of that same highway example in a crowded city with buildings and trees and such close to the highway. Now think of that highway running through a flat, featureless plain with something like wheat fields on both sides. Retrograde is going to be much more apparent in that latter example. Saturn will end its apparent retrograde motion in mid-November as the Earth rounds the bend again and Saturn appears to return to its more southerly shift night over night. Saturn is really far away, so it really only makes tiny movements, even over several days. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, for the Storm Prediction Center Tornado Database, 22 twisters were confirmed on June 25th, 2010. The strongest was given a rating of EF4. It traveled almost 14 miles for about 30 to 40 minutes through parts of Lyon and Osceola counties in Iowa. The tornado began 3 miles to the west-southwest of Little Rock. 2 hog confinement buildings were destroyed and 12 hogs were killed. Numerous other buildings received damage. The tornado strengthened in Osceola County and produced EF4 damage. At least 2 houses were destroyed, 2 people injured in one of them. 3 vehicles parked under an Iowa Highway 60 overpass were demolished. All the windows were blown out from one of the cars, and the front tire was lost. 11 people in the vehicles were injured. A car was tossed at one of the destroyed farmsteads, and the engine was thrown several yards. A silo anchored in concrete was toppled. Most of the damage in Osceola County was just to the west and south of Sibley. Check out all of our tornado history narratives at tornadotalk.com.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is foreseen. When colors blink, by night or day, precipitation's on the way.
It's hot, and that's the weather roundup for the week. James ate a lot. What was your high in Tulsa today?
We were 100 degrees 2 days in a row of 100, and if we hit 100 tomorrow, that'll be the first time we've had 3 in a row since 2012 in June. In June, that is.
I think we did 99 here today, but the dew point dropped down to like 58, 57. It was a very, very odd continental type air mass, which we'll take that. And the hurricane season so far is kind of calm. I guess we're watching the dust, the Saharan air layer moving across the Atlantic. We might see some of that down here in about 5 or 6 days, and that can provide some very vivid sunsets and sunrises on the Gulf Coast for those that have not involved that. So the MDR is kind of closed down with that for now, but we got to get into August and September, and who knows whenever NWA is, we know that's going to be the big hurricane week. When is this? The NWA meeting?
It's September.
Yeah, that's when it's going to break loose. And this year it's where? In
Irving, Texas.
Dallas, Fort Worth. All right.
Yep.
No, we all need to I need to get out there for that. I got a great DFW airport story, but we'll share that on another show here.
There aren't many of those right now.
Yes. So let's do picks of the week here, and we're going to go around the horn and see if anybody's got a pick of the week. So, and again, we're a lot of folks are on vacation this week, so we're kind of thin-staffed here. But hey, we are here. So Rick Smith got a pick of the week for us.
Yeah, my pick is something I just saw on the NBC Nightly News here just a couple hours ago. Had Josh Worman and Karen Kasiba and Jen Walton and others with the Doppler on Wheels crew. A story about one of the tornadoes in Iowa. One of the EF4 tornadoes in Iowa this past spring, where they had over 300 mile an hour winds measured with the Doppler on Wheels. And just a good little package on them, showing them out in the field and talking about their work. They do such great work, and there's a lot of people out there chasing and intercepting. And this big movie's about to come out about storm chasers and the different reasons they're out there chasing. This is Josh Worman and the Dow have been out there for decades doing this and just doing great work. So that's my pick.
Awesome. And we'll put the links up on weatherbrains.com. So when is the movie going to come out? Let's chase a rabbit here.
It is the release date is July 19th. That's when it goes out everywhere. They're doing some early screenings before that, like there's a whole bunch of us, Kim and me, and I don't know, 40 or 50 of our best friends are going to join up at a theater on the 17th to see it. But the 19th is the date to watch for.
And I would assume this will be a full theatrical run, so we can see it in theaters.
Yeah, it's a
then
$200 million Universal Warner Brothers picture. Yeah, they're doing the huge press tour right now, so you'll be sick of hearing about it for sure by July 19th.
But most importantly, when does your segment hit? What point in the movie?
I haven't seen it yet. I'm imagining it's going to be in the first 10 minutes or so. I mean, I think, yeah, I'm predicting, but I have all I've seen is trailers, just like everybody else. They are starting to do some screenings. They did a screening in Dallas last week, which I didn't know anything about, and they did one in Chicago. So yeah, we're going to start to see reviews, and the early reviews I saw from the Dallas screening, including a couple of TV Mets, were, one of them gave the meteorology in the movie a B, which I was pretty excited by. If it gets a B in meteorology, that's pretty impressive. So I don't know. Maybe they were grading on a curve. Maybe, I'm not sure, but yeah.
Now, and one more question about it, Rick.
Yeah.
When you went to makeup, what they put on you? What kind of makeup?
I don't know what they put on me, but we had to walk from the movie studio in downtown Oklahoma City to another building. And it was mid-May. It was hot, humid, even at 8 o'clock in the morning. By the time, and we had to walk up 4 flights of stairs to get to our little holding area. So whatever makeup they put on me, by the time I got to that, it was like gone. So it didn't matter. It wouldn't have helped much anyway. So
I tell people all the time, for me personally, paint on this barn will not help. So, it's just whatever. I mean, in my old days, forget it. All right, James A., give us a pick.
Yeah, and it's an important Hollywood movie making note that all of the main characters are introduced in the first 10 minutes of a movie. So, yeah, we look forward to seeing Rick in the first 10 minutes of the movie.
Yeah. Yep.
My pick of the week is and I'm going to butcher the name, Rapidan Dam, just southwest of Mankato, Minnesota. The dam this is floodwater up there. The dam is, the structure is good, but video of it's washed out the road leading up to the dam, and it's never good. That's one of the dam failure modes. That sounds worse than I meant it to sound, that you always worried about uncontrolled water getting on the other side of an impoundment like that. And that's what's happening there. And there's a ribbon of flash flood warning along that river that goes up toward Mankato. It's kind of a scary looking picture.
Yeah, I saw some of that video today. That's terrifying. We've had some horrible, horrible tragedies in this country as a result of these type of flash floods. So very intriguing. We'll put that up on weatherbrains.com. And mine is a lightning photograph. I love lightning photographs because I'm so bad at it. I hold my phone up and it's just this blurry little white line. For the people that understand how to capture lightning, some of this is fascinating. And there's a shot taken this weekend by Darren Hall out in Colorado, and that'll be my pick of the week. So having said all that, we're going to wrap this up. Bill Murray is not here, but I know we've got some good guests. I should have a slate here to tease. Let's see, July 1st, we are going to be here next week. Looks like we're going to have some folks involving the watch warning process from the National Weather Service. Rick, let's see, Aaron Treadway and Keith Sherburn. And anybody know them or where they're from?
I
here?
do. Yeah, they're the people who run the severe weather program for the Weather Service.
Oh, I forgot. Kim, I apologize. How rude is this? I thought you were chowing down at a restaurant in Joplin. Give us a pick of the week. You're still here. Go.
You're good. Yeah, no, my pick of the week is going to be something extremely special, as I'm sure all my comments have been while I'm driving. But I in lieu of being able to think of something particularly smart, I at least thought of something related to weather. My kids have been watching this YouTube, like a kid YouTube star thing that's kind of nerdy. And there's like us an episode on the planets, and it does talk about the different atmospheres of the planets, but it is the creepiest song I've ever heard, and my kids watch this on repeat over and over, and it has just millions of views. And if I have to see this, you all do too. And that is my pick of the week.
Great. I can't wait. All right, Kim, thanks. That's outstanding. But again, so we will be back on Monday nights through July 22nd. We'll do a Thursday night special on July 25th. And then we'll be back on Mondays for the rest of the year starting August 5th. But this was a great show. Great to have Cameron with us. And if you're new here, WeatherBrains is typically produced on Monday nights at 8 o'clock Eastern, 7 o'clock Central. And you can watch it live on YouTube, youtube.com/WeatherBrains. However, we know that most of you listen. If you would like to get in touch with us, the email address we all see it is email@weatherbrains.com. Jen Naramore typically does the email segment. She should be back with us next week. But again, send us a note if you'd like to get in touch with us. All the picks of the week will be on weatherbrains.com. But thanks for listening, watching, whatever you do. On behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a great week and God bless. Thanks, everybody. Thanks,
bet.
Kim, for hanging in there with us.
Drive safely, Kim.
Yep.
Yep, I sure will. Thank you guys. I hope that everything still sounded okay, but man, I couldn't miss Cameron. He's so good.
Yeah.
Absolutely.
Yeah.
No, you were